Yeah, I think it's being recording now, right?
It is recording now. Every time this thing, the window goes away, it's a problem. Me, the Zoom, sometimes I can't even find where it is.
Yeah, it's just it becomes an inset, sort of a weird small window, right?
Yeah, I mean, and it is not even clear where it is. Okay, so for example, it disappeared completely.
So on my, so here, for example, I can usually see Zoom somewhere over here. I think you might be able to see it in the dock below, which is usually somewhere
It's
down here.
usually there, but it's
Not there?
here. Yes, I got it. Yeah. Okay. Okay, it's being recorded now. Yeah.
Right. Yeah, so I think the simulation code, so okay, so let's basically maybe what we can do is go over the code piece by piece, and I'll say what I feel about the various pieces of code for each one of the projects, right? Just a sec, this is acting up for some reason. Let me just restart the Chrome. Yeah. Google Chrome seems to be lagging for me some reason. Yeah, okay. So yeah, so this I think is good. The ONNX loading code that you guys have already is good, but of course, the graph that you're creating, there might be some convention notation difference. For example, you are using tuples of indices as like the names of the nodes, right? Well, they are using something like strings separate with the indices being separated by the node indices being separated by underscore and so on, right? So there are some differences like that. Then, but other than that, yeah, I think this code can be reused. Like you just have to change this to something else, right? So I'm saying this code can be adapted to work with this one, right?
I think so.
Yeah,
Just
yeah.
different instruction.
Right. So yeah, in general, you think the ONNX loading code is there in your submission, Akori? And then after that, I think going to splitting ink deck and Posneg.
That is something that I have to explain because we want to change. We want him to change it to
directly doing ink deck,
yes.
right?
Yeah.
So this is something that we'll need to sort of rewrite in any case, right? So that is that. Yeah. Sorry, I couldn't hear you. What
I don't know.
Maybe for seconds.
You have to repeat. I think you are.
Yeah, I think you're breaking up. Sorry.
Yeah, my laptop ran out of charge for a minute. Can you repeat?
I couldn't make out what you said.
Hello?
Yeah, this is somewhat audible. Yeah.
It's hard.
Yeah.
I think it's.
Yeah. So if possible, like could you come closer to the mic maybe? I think it might.
The fan.
Oh.
Is it better now?
Yeah, this is somewhat better. Yeah.
Yeah, can you repeat that ink deck?
Yeah. Now it's better, slightly better. You could.
Yeah. So you were asking something?
Can you repeat the ink deck part? I got disconnected for a minute.
Yeah. So what I'm saying is that what both of you guys have done is you've done a Posneg split, right? And then use the Posneg split to do an ink deck split. There is a way which I had talked about, I think, in class as well, to do an ink deck split directly. And the benefit of that is that with the Posneg followed by ink deck split, you get 4 times the number, like the number of neurons increases by a factor of 4, right? Whereas if you do the ink-dex split directly, the number of neuron increases only by a factor of 2.
2, right.
Yeah, so that is something that can be done. And I think that is maybe a good idea to implement. So in that sense, I think this bit of the code we can't use from either team submission. So the index splitting needs to be rewritten. The simulation also, I think, should be rewritten, because see, while your guys' simulation doesn't have any bugs, it is, I think, unnecessarily, like, for example, you're creating these PyTorch models, right? This is kind of unnecessary, right? I don't know if you're familiar with this part of the code, because it might be some other person wrote it. Are you familiar?
I'm somewhat familiar. I went through it.
Okay, yeah. So see, basically the thing is, this is like there is no need of this class over here, right? You all you're wanting to do is simulating things, and you already have somewhere here some functions to convert the one layer into, see, so you already have a function that will convert a layer into a weight matrix, and similarly for a bias matrix. Once you have these functions, all you need to do is just like matrix multiplication, right? You don't need a full-fledged NL.module. The only thing that writing a class like this gives you is that it gives you backpropagation for free. Here we're doing just simulation. We don't need backpropagation, right?
True.
So this bit is I think this code I think should be rewritten, or at least cleaned up to the point where it's like these classes are not necessary, right? And their code, their simulation code is of course buggy, so I don't trust that per se, right? So again, what is the simulation code? Yeah. Yes, this one also I don't trust. So simulation we'll also have to rewrite. So in the part one of the algorithm, we'll have to write the parser, we'll have to write rewrite the simulation, and we'll have to rewrite the index split. I think the interval propagation can be taken from here. Right? So this interval propagation code, I think both of the teams' interval propagation code are fine. So we can take either one of them. So interval propagation we can take from either one. Right. This is something that we can take from either one of them. And I think this code is actually much simpler than the other team's interval propagation code. So maybe this one is the one that we would want to take. Yeah. Then step 2, both of them are fine. So if we are taking this code so far, then we can take step 2 from here as well. Step 3 is something that we'll have to figure out. Right? Okay. So sir, how should we do this? Firstly, are we going to only take it from, so firstly, do we even, okay, maybe even before answering this question, let's make this table of which code we can take from where, right?
I mean, I don't know. I mean, see, I want some quick, I mean, I was thinking, well, maybe I mean, from that point of view, I mean, whatever requires least amount of, what do you think, Akauri? I mean, I was going to say to use Rohan's code, okay? Because if you use that, if the only thing that was required was integration
You
of.
can't run a castle.
Huh?
They can't run a castle though.
No. The reason that you can't run a CAS is only because the parser is not integrated. Correct.
Right.
But if the goal is to do that which requires least amount of effort in testing, if you mix and match too many parts of it, then the compatibility question comes. You will end up having to fix too many interface issues, isn't it?
Yeah, I don't think mixing and matching is a good idea either.
Is it? It's not a good idea, saying.
Yeah, I don't think it's a good idea either.
Mm.
So I think if we have to choose one of the two codes,
Mm.
then it's a good idea to sort of make a list of like comparing which section of the code is good from. So like which code we should take to have the minimum amount of rewriting, right?
Mm-hmm. That's
Hmm.
Right. I think see the ink deck we have to write anyway.
Mm.
So I'm talking about, let's say, Akodi's code right now.
Mm.
So with Akodi's code, we have to rewrite the ink deck. We don't have to write a parser, and we have to simplify the simulation part of it. I think in the simulation part, so we just keep
Yeah, but that's right. The
right.
simulation part, they are using TensorFlow, correct?
Yeah, which is fine, but the way they're using it is weird. So for example, delete these. There is no need of these classes anywhere. Instead, whenever you're calling the forward, see what all you're doing when you're calling the forward over here is you're applying these linear layers, and you've somewhere set it up so the linear layers match with the weights and bias matrices you're getting from here, right? So what I'm saying is that for the simulation part, all you need to do is call these to generate the weights and bias matrices, right? And that again is just going to be like, this is just a list of lists, right? And similarly, this is also just a list. So once the weights and bias matrices are made, you can then convert them to a NumPy array, and then you can just do matrix multiplication. So that will be, I think, a very fast way of simulating things, and also very simple in terms of code. This code will get reused. You don't want to rewrite anything over here. Then this code you'll have to get rid of. And yeah, that's about it, I think. And then when you're going to simulate DNN, or you have something, a single layer iteration, right? In single layer iteration, you don't need to do any of these. All you need to do is one weights and bias calculation, right? So in simulate DNN, you just entirely convert everything. You get the layers and you convert everything into weights and biases. And then for each one of them, you just multiply it with the weight matrix and add the bias vector and so on, right? So that is some amount of rewriting that needs to be done with this code. Then I think the rest of it is fine. You have, I think the way you're naming things can potentially be an issue, but I think at least it should be fine, right? In terms of ink deck and so on. So like adding ink deck into the name, but I think it should be okay only.
Yeah, but then they'll have to, the major thing if they use Cowdy's code, team's code is the last part. Step
The
3
last part
will
will have to be
completely done from scratch. No?
right. So in terms of the last part, see, this is the part you are sort of very familiar with, Akodi, right? Right. So do you have any idea why this is happening?
I'm not sure really, but
Yeah.
I'll check again and again. I'll tell you.
Right. So see, I mean, if it is saying it's unbounded, then it somehow means that something's like the direction of some bound is
I
reversed
tried
somewhere.
both ways. I tried both ways.
Okay.
I'll check again. I'll check.
No, that's fine. But like I'm saying, just yeah. Right. So this is, yeah, so this will have to rewrite completely. And also, you don't have any way of encoding Marabu, right?
Not correct.
Yeah. Because you're just reading this so there's like the subnetwork to ONNX file doesn't come from anywhere inside the code, right?
When we
Like-
were making the project, we talked about making a subnet of ONNX, but we couldn't finish it in time.
Right. So there would have been a corresponding subnetwork to do it, like corresponding, yeah, function that dumps this .onix file, right?
Exactly.
Yeah, yes, that is not, yeah. So this, yeah, this will have to, there's quite a bit of work that will probably need to be done over here in the last part. So for Caudy's code, there is rewriting the simulation. There is work that needs to, like this last part needs to be, I think, a fairly significant amount of work needs to be done here. And I think that's it, right?
Did team one's step 3 work?
Yeah, so they haven't tested it on ACAS, but on their small example, it does work. I'll show you.
All right.
Yeah. So see, they're even producing a merged network and everything.
Hmm.
So in that sense, their code is like much more complete. So their step 3 does work. Okay. But then again, this is the not code that you have written, right? So it's not like you'll be particularly familiar with it while working with it and so on, right?
True.
Yeah. But apart from that issue, I think this step 3 works. So if you want to use their code, what we'll need to do is
I'll use my code, but I'll use team one's for reference.
that is fair, but like
Oh, I see. So you will kind of read their code and then kind of create
Right.
your own. That may be a good idea. So at least for coding, huh?
yeah, because then we'll have something that we know
Correct.
more like understand more deeply, right? Because if somebody from team one was here,
Mm,
then we could have told them like, okay, look, we are using your code. What do you do here, right?
I think so. Yes, I agree with that. So
Right.
I agree with Corey's suggestion. Okay, you can look at the code. So that way, it'll probably speeden up a little bit now. Huh?
Right. Yeah. And I think even in team one's code, if we were to use their thing, even there the sync tag rewriting is there. And even there, I also want to sort of rewrite this interval propagation code because this is, I feel, unnecessarily complicated again in team one, right?
Okay.
So I think even there, it's not like at least up until like if you remove the idea of remove the step 3 part of it, the amount of work in terms of rewriting that needs to be done in both is out of similar. In fact, it's slightly more in team one, I think, because there both the simulation and the interval propagation will need to be rewritten. So in terms of work, if we go with Akari's team's code, then it's just the simulation that needs to be rewritten and the entirety of step 3, which we can use team 1 for reference. Whereas if we use team 1's code, then we'll have to rewrite simulation and interval propagation. But then we will have a lot of code which we may not understand very deeply. So that may or may not be an issue in the future, but yeah.
Yeah,
So-
but then step 3 code has some bug which might be hard to debug, huh?
Yeah. I mean, you see, right now it works on their small train network, right? But if there is some bug which we haven't found up until this point, then yeah, it's going to be hard to debug because we don't know what's going on here in general.
I mean, getting ownership of your own code, okay, is always easier to debug.
Right.
Worst case scenario, I'll bug them and ask them what they did. It'll be on campus this someday.
But right now, what is the plan then? Are we going to rewrite step 3 in your code in a Codis team's code by referencing team one submission?
Yeah,
That's
that
what it-
should be.
Mhm. Yeah, okay, sure. So that will be one. And then the other bit of the thing that needs to be done then for this implementation is, so okay, so this then it's not just step 3, but also you see after the end of step 3, there is this thing which will be get abstract network, right? Which is the
Okay.
actual getting the merged like network after one merge. This code should also be written.
the one where the merged subgraph is
Yeah.
replaced
With
by,
one neuron.
by the merged neuron. See, but before that, there is this encoding, Marabou encoding. Okay, that is
Yeah. That is all I'm including inside
And
step
the
3.
Marabou encoding, can that be reused from the other teams?
Yeah, it's just that see the graph is indexed by different objects, right? So that bit of translation needs to be done. Other than that, yeah, it can be
The
reused.
difference just for renaming the basic structure the same?
The basic structure is the same. The difference is renaming, but yeah, I think the difference is just renaming. So perhaps even it shouldn't even matter much.
How long? I mean, the Marabou encoding, that
Mhm.
is, it's a long, it's a fairly big code, isn't it?
This code, this much.
That's it?
Yeah. So this actually doesn't depend on the name scheme these guys are using for their graph nodes. So
No, it doesn't
theoretically,
depend on the name, I understand. But then if they're creating some logical names based on the names that they've used, I don't know. Okay, because you do need some names, logical variable names in the Marabou encoding, no?
no. So in Marabou, it's all given by like variables are references by indices, integer indices.
By indices. Okay.
Yeah.
Okay. But if the rest of the structure, as long as the rest of the graph structure is the same,
Right. Then it should
then
be.
this, you should be able to pretty much use this.
Yeah. It'll just be. Yeah, I think you should be able to. I think it's like it might just be differences in, the format of the merge group, what it expects in input nodes and out node. I can't say with 100% confidence there will be no interface issues at all. But definitely, if you want to take this, read it and rewrite, I think it should be very easy. So if you're reading this and rewriting it, Akori, think that should be very easy. Or if you want to completely reuse it as is, that also you can do. You just have to figure out whether or not some interface issues would be there, for which you'll have to do a somewhat deep reading of the code anyway, and at which point you can just rewrite it to fit your interface, right?
In this connection, how have you made any progress with Madhukar's student?
No, not yet, sir. So yeah,
Is it? And I was, so we have two options. One is, okay, either getting her involved because she would take some time to get up to speed, isn't it? Huh?
Yeah, but I think eventually we will have enough implementation to do where I think it's a good idea to have both.
What I'm saying is, should we start integrating that? Or I think because Akauri kind of knows, and since
no, I think we should definitely start.
Then
I think
we start what? Okay,
this part, the rewriting of step 3, so that it fits into.
So my question is, Akauri should not eventually will involve, but not mix the two. So Akauri should be working by himself in making these fixes, isn't it?
Yeah, I think so. I think definitely, because we have been working on step 3 anyway, right, Akori? So maybe you could right now fairly immediately just start looking at step 3 as the other team as a reference and implementing it in this project, right? Is that okay?
Yeah.
Hello.
Sure.
Yeah. So
Yeah.
Yeah, but I think in
So,
order to help him, we can have some, code reviews together. Okay, you can write some things, and then we could do.
Oh, definitely, yeah.
Yeah, I mean, even if it is, let's not wait for a week and then, what I'm suggesting is like even alternate days or something like that.
Yeah, definitely. So I mean, it all depends on like how much or how often you want to meet and how much of work
No,
you'll
I
be able
think
to
that
do.
he will decide, because he does not. He says that one nice thing is that he has only 2 courses, okay, or three.
Three
Ah,
okay.
okay.
So what all
Okay.
courses are you taking?
NLP, computer
Mhm.
vision, and applied machine learning.
Nice.
All my courses are on Tuesdays and Thursdays, so I'm free on Monday, Wednesday, and Friday.
Okay, sure. So we can do this then. So we can meet on Friday next,
Okay.
yeah.
right? Yeah, and would you be able to read up some of their some of this? I'll send you this notebook, of course.
Okay.
Would you be able to read up on some of the implementation of step 3 that they've done? Maybe pick
Yeah, sure.
maybe pick one algorithm. In fact, algorithm 4 is the one that you were stuck at, right?
Yeah, SIPI had a problem because unbounded.
Right. Yeah, so maybe what you can do is look at what they have done and read the code, see if it's making sense, and see if you can write it in your notebook and if it begins to work.
Okay.
Okay.
Hmm.
Yeah. And eventually we will, so keep this in mind. Eventually we will probably have to move out of a notebook into a standalone application sort of situation, and that's okay with you, right?
I don't have much experience, but I'll read up on it.
Yeah. So, yeah, it's just that it's a sort of different environment of writing and like coding. For now, we can just keep it in a notebook, but eventually that'll have to be the format because it's much easier to run it like multiple experiments that way. Okay. So yeah, but just keep it in mind. And one thing you should do in that end is if you notice that they have defined things as functions, right? Whereas in your when you're implementing algorithm 4, it's just some code in some cell.
Yeah.
Right. So don't have it like that. Just try and put it inside a function if possible.
Okay.
Which you've done in the the other guys have done in the other pieces of code, I think. For the most part, not always, but for the most part. Because that way, what we can do is later on when we convert this into a standalone thing, the functions we can just copy paste as is. We don't have to worry about it at all, right?
Right.
Whereas if you have coded the cell, now you have to think about okay, where should this code be? Should this be inside a particular
different
function?
cells, different blocks.
Right. You have to separate it out more nicely, right? Because here you get a separation between cells, but there you'll have to do that in some other way.
Okay.
Right?
Yeah.
So yeah, so basically I think algorithm 4, if possible, you can start and then read through it and then see if the code makes sense. If possible, you can also try writing some code and testing it, and then we can meet on Friday and see what the
algorithm 4 is the encoding, correct?
Algorithm 4 is the LP call.
Course bounds.
Yeah. Course bounds. Yeah, this is the one where they had got stuck. This is the one where the unbounded issue is happening. This is
By the way, I think, as a priority, we should eventually do that direct ink deck thing.
So
we can defer that, okay? Because, right? But the question that I'm saying is, do you want to describe how it is if indeed it is not?
Sure. I can do that right now. I'll just connect the Wacom tablets
so that Kauri will come on them in, because I wanted to hear that as well.
Yeah, right, sure. So so let me describe that, and maybe what we can do is since that is somewhat independent. While Akruri is working on step 3, I can talk to Madhukar, I can talk to the student and see if
she can do it, huh?
If possible, I don't know if she'll take
Yeah,
some
but
time to
then
get
if she
up to
does
speed.
it as a code, okay, she could do that. That's a good thing. But let her then use the, so if you want to integrate it, because that is dependent on the data structure.
Oh yeah. So there I'll sort of
And if we have decided to use Akaudi's team's data structure, then you should use, she should be doing the same thing. Huh?
right. So then maybe we can all sit together and like explain the data structure in detail to her at some point before
Yeah.
she starts implementing, right?
Yeah, so that will be like a kind of a in self-contained task that she can do, no?
Right. I at least think it should be somewhat self-contained.
Yeah. Then
Okay.
if we integrate and have a code together, review together, she will also be.
She'll also so if we have a code review together, she'll understand what the data structure is, right?
But
And
you
then
have
she'll be able
already
to write
shared
it.
the algorithm, so she should maybe discussing the algorithm. She should be reading that now. Huh?
I'll explain the algorithm to her, and I think even Madhukar can do that, because this was something that Madhukar told me. This direct intake was something that Madhukar told me few months back, I think.
Uh-huh. Mm. Oh,
So yeah. Okay, so I'll
so
explain that.
very briefly, explain how it works.
Yeah. Right. So basically, it's again going to be inductive. It's going to go from the last layer to the first. Let's suppose that somehow we have some nodes in the next layer that we've already marked as ink deck, right?
Mm.
So we know that this is ink, let's say. Okay, let me maybe draw 4 nodes here. Let's say that this 2 are ink and these 2 are deck, right? Now let's consider a node here. If let's say that this node has got 2 edges that are going to these 2 nodes, and the weight along both of these 2 edges are positive, right? And then what does that mean? Then it means that if we were to increase the value,
you had on the chat said something that something is lagging in your internet.
It's
Are
fine.
you able to
It's
see
fine.
what Diganta is writing? It works now. Okay.
okay. Yeah. I'll just have the chat open. So if you think that you're not audible but you want to say something, you can just say. I can see the chat, by the way. Okay.
Cool.
Okay. So yeah. So let's suppose that we have one node like this, right? So let me just draw all 4 edges. So now let's say that these 4 edges, they are positive, and these 2 edges have positive weights and these 2 edges have negative weights. Okay. So now what would happen if you were to increase the value of this node? If the value at this node were to increase, then the value going along these nodes would increase, right? And then so you would see an increase in the value in these 2 nodes, right? And then the value going along these edges would decrease because there's a negative weight, right? So values reaching these nodes would decrease, right? So you would see a decrease in the value of these nodes, correct? So remember that the ink deck classification, what does it say? It says that if a node is marked as ink, it means that you are allowed to increase the value of that node. And that is going to be sound. That is going to be a sound over approximation, right? So we are allowed to increase the value of this node, and that will still be a sound over approximation. Similarly, if an over approximation increases the value of this node, it's going to be sound. It should decrease the value of this node, and it is allowed to decrease the value of this node, right? So now what we see is that because these weights, the weights corresponding to the ink marked nodes are positive and the deck marked nodes are negative, we can actually safely classify this node as ink, right? because we are always allowed to increase the value of this, right?
Right. Right.
Does that make sense?
Yeah.
Is it also okay with you, sir?
Yeah. I mean, this is a sub case, because if every node feeding into that ink node in the next layer has positive weightage, then you can safely class, and similarly a negative weight. Okay, if there is mix, then you are in trouble. Correct.
Right. So notice here, yeah, exactly. So notice here that this node,
Negative weights of deck.
sorry, I couldn't hear you. Can you maybe you can type it in the chat if
Yeah, negative weights are with deck. That I understand. Okay. But
yeah.
this thing was, if there is some negative weight, some of the edges. No, that can't have. Yeah, if what happens if the weight on the edge going into the ink node is negative, then
Then we'll have to split.
you have to split. Huh?
Then you have to split. Yeah. Then we'll
Okay.
have to split.
Not
So if
that-
this is the situation, then we'll have to split.
Then you have to split. Okay.
Yeah. Yeah, but in this particular case, we notice that we actually don't need to split. We can actually safely just mark this as ink.
Okay.
Right. And why I'm pointing out this is because, yeah, this is worst case scenario, there will be two splits. And notice here that we didn't have to do a pause next split, right? This node actually, this node is neither pause nor neg, right? You can't classify this as pause because we have two negative weights here. And you can't classify this as neg because we have two positive weights here, right? So this node is not pause. It's also not neg, right? So, but still, because the weights of the edges and the ink deck classification of the nodes of the next layer, because they match in some sense, we can still safely classify it as ink, right? So similarly, we also have another sort of nice case where, let's say that all the weights, okay, so maybe I should, yeah, I'll destroy it here. So let's say that all of these weights are negative and all of these weights are positive, right? So now we can safely mark this node as a deck node, right? Because if you decrease this, these things will decrease. The value along these edges will decrease. So the value over here will decrease. So, yeah, the value over here will decrease, right? Sorry, I messed up. What I meant to say is that if you decrease this node, then since the weights are negative, the value along these edges will increase. So the value at these nodes will increase. And if you decrease this node, since the weights are positive, these will decrease. So these will decrease again, right? So you're safely allowed to decrease the value at this node. So you can safely mark this as deck.
Overall, it will still increase the output. Yeah.
Yeah, overall, it will still increase the output. So this way you can actually do this. And if you have a situation where the where you have, say, a mix of like the weights of the edges and the ink deck classification, they don't match and there is a mix, then you'll have to split. So if you have a situation like this, for example, where again, let's say that we have 4 nodes over here. This is ink, deck, and now this one's positive, but this one's negative, and this one's positive, but this one's negative, right? Then you have to split. Then this will get split into an ink node. And the ink node is going to take this weight and this weight, right?
Yeah. So you will split the one behind. Okay.
Yeah, like this is the one we were trying to classify, and since we can't classify this is the one we'll have to split, right?
So, but after this, when you merge,
the merging is going to be the same.
The same.
Yeah.
Okay.
It's just the splitting is different. The splitting and the classification is different. And similarly, there'll be another deck over here as well. So this is going to be our ink. This is going to be our deck. And the deck is going to take these two edges. This one from the negative one, and this one from the positive one. Correct?
Yeah, I think he has some comments.
Yeah, let's see.
Yeah, okay, that's correct. Worst case scenario.
Yeah, worst case scenario. Yeah, I think I saw this one before also. The worst case scenario is two splits, right? So you never end up in a situation where to split more than split a neuron into more than two pieces. Okay, so is this clear?
Yeah.
Does it
Yeah.
make sense? Yeah.
Yeah.
This is the algorithm that sort of one for the ink deck split part.
See, then what she can do is, when you talk to her, you can actually share the code, Kauri's code, no? Then they can change it to re-implement, no?
Right.
Or if she wants to, as long as she preserves the data structure, it should be fine.
Right. Yeah. So what we can do is I can share the code at some point. Kauri, if you want, can you explain the data structure to her, and then she can start implementing this?
I'll try to summarize. I mean, I'll read it myself first, and then I'll be sure.
No, but you know the data structure, right? So you have worked with the code.
Mostly, yeah.
Yeah. Okay. No, so this, by data structure,
team ones, I don't know.
No, I'm talking about. I'm not talking about teams ones. I'm talking about your team.
Yeah. I can explain.
Yeah. So I mean, by data structure here, all I mean is, okay, what are the nodes of the graph, right? Like you have 1, 1, pos, ink or something like that, right?
Yeah.
So in this case, it'll be just 1, 1, ink, right? What are the nodes of the graph and so on?
Right.
So those kind of things you'll have to explain. What are all the attributes that you might need and so on? Okay.
Okay, so by Friday when we meet, what is it? And he would have looked at the encoding code, no?
Course one.
No, so the course one, the LP call code.
Oh, the LP call code. Okay.
Yeah. I think let's I think we should get the LP call done and then go on to the other ones.
Okay.
Because then we can use that code.
The LP call code, to check its correctness is also that approximate thing. It has to be done on some small examples because it has to be done manually. There's no.
Yeah. So the LP call code, the issue is, this is actually in general an issue, right? Because see, if the LP call code, it gives you some result. So right now it's giving you unbounded, which definitely shouldn't happen, right? So in some sense, this we know is definitely wrong. But let's say that it does return you something. How do you actually know that, that is the optimal bound in that case, right? How do we actually test the code once it's written? That is a question that I don't have a very good answer to, or I didn't have a very good answer to while grading, at least. I think one of the things that can be done is see, if possible, take a very small merge group and and generate, say, 5 simulation values, right? And then on those 5 simulation values, if you were to, let's say the merge group is also got only, let's say, 2 inputs or 3 inputs, 1 output, 5 simulation values, then, we can at least dump out the LP problem that is being generated, like right before you're calling LP. So here you're calling LP over here, right? So you can dump out A underscore UB, B underscore UB, and see if that is making sense, right? So are we actually seeing that, okay, whatever the bound is, it should be above this particular point and this point and this point and so on. And it should minimize the volume being this, this, and this, right? Is at least that making sense? So we can dump out this sort of a tuple. And that is, I think, at least the only way I can think of sort of sanitizing and making sure that this is kind of works, right? Okay, because yeah, even their code, like I'm saying, it works. When I say it works to the extent that they're producing something, right? So if I go down, I think it's, yes, you see, they're producing something. But I mean, there is no way for me to understand whether this is correct or not, right?
Everything 0, yeah.
Yeah, because I mean, sure, it might be that in this case, 0 is the best possible bound. It might not be, right? How do I know whether it's correct or not, right? But if the LP is small enough, and the LP will be small if you take, say, 5 simulation samples for testing purposes, then what you can do is you can dump out this tuple. In this case, this is where their tuple is, right? So you can dump out this tuple of V, AUB, BUB, and you can see if that sort of makes sense manually, right? You can then you're in a position where you can manually check that. If the LP is small, then the LP will be small if the merge group is small and if the simulations are small. So once you've written the code, you can sort of test it on one such very small merge group with with very few samples and see if it's making sense, right?
Right.
Yeah. Okay. So
yeah. So in summary, then the decision is to use Cowrey's code, correct?
Yeah.
And just use the portions. Which is use the other team's code just as a guide. Okay.
Yeah.
Write those parts, the code for those parts that have not been implemented, specifically the step 3. Yeah.
Right.
And for Friday, we will concentrate. Cowrey will just have some sketch of a code for computing the approximate bounds.
Right. At the very least, like if possible, just read and see if you understand their code. And if there are any questions, then we can try and figure that out. And beyond that, if possible, start writing some code, basically. Yeah.
Now you will separately, Diganta, will talk to Madhukar.
Yeah.
About this plan. Okay.
Right.
Of doing that, and the information and some documentation about the data structure. How will that be conveyed between Cowrey and?
I think we should set up a meeting where Cowrey explains it to San and Madhukar.
That can happen. It's already today's Wednesday, so that can happen sometime next week. No.
Yeah, okay. That can happen next week or.
Huh?
Yeah. So is tomorrow?
I mean, I don't need to be there for that. Okay.
Right. Yeah. Yes, I think that can happen next week.
You check with Madhukar and Sahan.
Right. I think it'll, yeah. So I'll check with them and then I'll ping you a code. Okay.
Cowrey, if you need to be available, I mean, he will be available Wednesday. No, Cowrey?
Yeah. So I'll ping you if
wait a minute. Wednesday he has courses. No, wait a minute. Thursday he has courses. So tomorrow it can't happen, okay, because he'll be busy.
Okay, sure. So then start tomorrow, and then Friday anyway we are going to sit. So I don't know if you want to have 2 back-to-back meetings. But yeah, I'll talk to Madhukar, and I don't think they'll have some constraints on their end as well. So what I'll do is I'll coordinate and let you know, okay?
Yeah, but I mean, I think this sharing what the data structure is, you can do offline also. You can just write a brief description and actually show
Okay.
the structure. Huh?
Sure. So that might also work. In that case, in fact, I think what can be done is that one description would be good, but also some test cases, which I think, so I don't have it in this particular notebook, but in the previous version that you submitted, I had added in some test cases. And I think I shared it with you guys as well as a part of the mail that I sent you. So those networks, or maybe even a smaller version of that network, can be used as a test, right? And there I was adhering to your data structure in some sense. So at least as best as I could understand it from the code. So yeah, so if that is another possibility, like if you can sort of write up a description with some test cases.
I think that will be good, because in any case, that will help all of us come on the same
Yeah,
page.
understand. Yeah, makes sense.
Yeah. So yes, I think right now you do step 3. I'll let you know if like about the data structure and the test cases, right? Because I think right now you should get started on step 3. It might still, like, I'll have to still explain the actual algorithm to Sana and all, and then or Madhukar will have to do that, and then she can get started, right? So that might still take some time. So maybe Cody, you can just do step 3. Is that okay, sir? Right now?
Yeah, but that's what we just agreed, no?
Okay,
Yes.
okay. Yeah, sure. Then I was sort of getting
No. So what you're saying is, yeah, I mean, how exactly that will be communicated, in what fashion, etc., that can be decided after you speak. Yes.
Yeah.
This is what you're suggesting, correct?
Yeah.
Yeah.
Sure. Okay, so is that
Yeah,
all?
that's all. Yeah. So what I will do is, I will save this, and I think I'll upload it on the SMT for DL page. Yeah. So
Mhm.
how you can access it from there? Huh?
All right.
Okay. So I'm going to stop.